can I get, Matt, the expansion for x plus y all to the power of 0? What did you get? 1? Okay. Harry, what was the expansion for x plus y all to the power 1? It is x plus y. Now, you've been doing binomial expansions for a while, so you can use FOIL to write something like this, because this is just x plus y times x plus y. And Joel, what did you get for this one when you expand it all out?
It is x squared plus 2xy.
Yep. Awesome. Now, when we get up to these ones, these are cubic kind of expansions, right? This is all to the power 3. Still a binomial expansion, just power 3, sorry. Right? We can make this easier in some, because you know that this is just x plus y times x plus y times x plus y. But to make it easier yourself, what can you do? Yeah, you know that this is just this guy here. So I can literally replace x plus y times x plus y with what I have here. Now, when you think about expansions, right, I've trained you, or hopefully I've kind of reminded you that something like this is not, I'm going to do it in red because I don't want you to do it, is not equal to this guy here, right? That's not what that means. We have to write out that expansion fully, and doing this way is going to hopefully make it easier. Eva, when you expanded this, so I'm multiplying everything on the inside by the outside, right? What did you get for it when you expanded it all out? Yeah, so if I was to do it here, right? X times x, that's x cubed. X times x here, well, that's 2x squared y. And then lastly, we've got xy squared. And then, when you've got a wrong room here, then we have to do the y's as well. So what would the y's be? Yeah, x squared y. Yep. Plus y cubed. Now, what you notice is that there's actually some like terms here, right? You have these ones, and then you have these ones. So I can group them together. So that's x cubed plus 3x squared y plus 3xy squared plus y cubed. Now, at this point, you're kind of like, hang on. All right, this is just really long and painful. There's got to be a better way to do this, right?
What's the new permutation?
I'll come back to that. It's a good question. Now, x plus y all to the power 4. I won't bore you with the algebra as much as I'd love to do it. Does someone have an answer for me that I can just write?
X 4.
Yep.
Plus 4x cubed y.
Mm-hmm.
Plus 6x squared y squared.
Yep.
Plus 4xy cubed.
Mm-hmm.
Plus y 4.
Okay. Now, I want to highlight something interesting here. If I take the coefficients of these expansions, so the coefficients are just the numbers in front here, right? I'm going to arrange them in a specific way. I think I'm going to write them. So I've got 1. What are my coefficients here? I've got just 1 and 1, right? Because the number in front of them is just nothing there. What about this one? What are the coefficients? 1, 1, 2, 1. What about this one? Oh, careful. 1, 3, 3, 1. And what about this one? 1, 4, 6, 4, 1.
Let's do it in descending order.
1, 4, 6, 4, 1. So keep in mind, right? I've written out my expansions in a particular way. I've written them out in the decreasing powers of x. I've started with the biggest power of x I can see, and I've written them in decreasing order like that. Okay? When I arrange them in this way, and when I arrange them, the coefficients in particular, I get this particular number pattern. Has anyone seen this number pattern before?
It's a triangle.
It is a triangle.
Triangle.
I want you now, on your sheets, I've actually printed out a larger version of that on the sheets that I've just handed out. Right? Have a look. Can you see any patterns? Can you see any patterns that exist in there?
They all have one.
They all have ones. Where?
At the end.
At the end. That is one of the patterns I'm looking for. I'm actually looking for 3. So that's one of them. They all have ones at the end, or at the ends. What do you mean it's plussing? What pluses? I don't think that's even a word, pluses.
I really want to see it.
What do you mean? Or like, what, 3, what? 2, 3, 4? What does that mean? What do you mean pluses? Oh, okay, yep. That is a pattern, but not the one I'm looking for. Any other patterns? Any other patterns? Any other patterns? Give me, someone got the next row. What is the next row?
It will be 1, 5.
Then 10. What's the pattern here? How did we get that? There's still ones on the end. And this is going up by 1.
Look, it's going up triangle numbers like
Oh,
this.
and this way, what did you say? We do have triangle numbers. And the triangle numbers, if you don't know, by the way, are the numbers you need to create a triangle. So like 1, I don't know why 1 is, it doesn't really count. 1, 3, what's that? 6, 10. Okay, the number of dots you need to create a triangle in that pattern. We call those the triangular numbers. That is a pattern. Still not the one I'm looking for.
What?
I'm looking for 3.
Do we have 2 at least?
What would the next one be? 1, 6, 12.
What would the next one be? 1, 6, 12, or 15. Why'd you get 15?
Because 5 plus 10.
Ah, that is one of the patterns I'm looking for.
Like, I didn't know how to explain
How do you explain it? What? Say it again for me. What do you mean 5 plus 10?
From the puzzle game.
What do you mean 5 plus 10?
Well, the 2 things are on top of it. 5
The
plus
2
10
things are on
will
top of it.
Add to
Hmm.
make the thing.
That is one of the patterns I'm looking for. Right? If you look at the 2 numbers above any other number on the row beneath, if you add them together, what do you get? You get that number, right? So 3 plus 3 is 6, 3 plus 1 is 4, 10 plus 5 is... Yeah, well, the one on the next row will 20 plus 15 is 35. So, if we sum 2 numbers, and they have to be next to each other, we get the number on the next row. Get the number below, say. So we sum 2 numbers and we get the number below. Now this next one, the next one is a bit trickier to spot. And it's not immediately obvious. So what I'm going to get you to do is, I'm going to give you a hint. I want you to sum all of the numbers on each row. Sum all of the numbers on each row. Has anyone got it? When you sum them up, the first one is obviously just 1. What's the next one? 1 plus 1 is 2, 4, 8. What numbers are these? What's squared? 8 is square root of 8. I guess that, yeah? Powers of 2. Ah. What do you mean powers of 2? 2 to the power, what's this one then? 2 to the power 1 is 1? Oh, okay, we start with 0. 2 to the power 0, 2 to the power
1, 2, 3,
Mm.
4, 5, 6.
So, my third pattern is the sum of the rows, they give powers of 2. They give powers of 2. Why is this a thing? Now, I think this is awesome because what's happened here, right? What's happened here? You actually don't need to know anything about binomial expansions to get these numbers because how this thing starts, it's called something called Pascal's triangle. And it's essentially just kind of having a play with numbers. If I start with these numbers, 1 and 1 and 1 here, if I just keep adding these numbers, I can go on forever and keep creating these rows and rows of Pascal's triangle, right? You can keep adding these numbers to get the next number and the next row and keep going on and going on. We just get these cool patterns like that the sum of the rows gives powers of 2. But what it turns out is that this is particularly useful for when I'm looking at binomial expansions. Why is that? Because you guys saw how painful it is to try and expand out 4 brackets of x plus y. But if I was to go to, let's look at x plus y all to the power 6. All right, if I look at x plus y all to the power 6, and I had the 6th row of Pascal's triangle, right? So this one here, let's rub this out so I can see that more clearly. Over here, right? if I want to write out the expansion, what do I want to do? Well, what numbers do those represent over there? Where did we get these numbers from? They're the coefficients. So if I want to expand x plus y all to the power 6 without, starting from scratch and going all the way, I can use Pascal's triangle. I can cheat a little bit. I can say, I know what the coefficients are going to be. I know they're going to be 1, 6, 15, 20, 15. I'm running out of space here. Let's fill that out. 15, 6, 1. Those are my coefficients. But remember, we had to write out the powers of x in a specific order. What was that order?
Go down.
Yes. Do you want to put them in for me?